Welcome back, Algebra 2 students, to another Regents review video. These are going to be the solutions to the Algebra 2 Common Core June 2017 exam. These are going to be the long ones. These are the solutions to the parts 2 through 4 of this exam. These are the short answer sections. Usually these are the trickier ones compared to the multiple choice, but we'll see how we do. Since this is a tricky exam, I think it's harder than the geometry regions, but make sure that you do not, under any circumstances, cheat off of this video. It is so not worth it. So not worth it. Make sure that you hit that subscribe button down below if you like the content that you're seeing. Consider becoming a patron on my Patreon page or visit my website at www.nysmathregensprep.com for more math content in Algebra 2 and your future mathematical subjects. And make sure that you purchase the TI Inspire CX calculator, one powerful tool. That link can be found on my website as well. And without further ado, let's jump right now to the part 2s, 3s, and 4s of this exam. I want to get done with it. I want to get this done quickly, but not too quickly because I need to explain things, but it does take a while and your time is precious to you. So here we go, part 2. Given r of x equals x to the third minus 4x squared plus 4x minus 6, find the value of r of 2. Easy stuff. You were just taking that 2 value and you're plugging it in for every time you see an x. So this is really your x value. So to find r of 2, you're taking the 2 and you're plugging it in wherever you see an x. So we get 2 to the third minus 4 times 2 squared plus 4 times 2 minus 6. R of 2 is equal to 8 minus 4 times 4 plus 8 minus 6. So we get R of 2 equals 8 minus 16 plus 8 minus 6. Continuing to solve, 8 plus 8 is 16, 16 minus 16 0, so all of that wipes out. So we get R of 2 is equal to negative 6. So that, ladies and gentlemen, is how you do that part of the question. Now for the second part of the question, this is rather interesting. And I hope that you know it, and if you don't, then know it. Make sure you study it. What does your answer tell you about x minus 2 as a factor of r of x? Explain. So they're asking you if x minus 2 is a factor of r of x. So we're going to say x minus 2 is not a factor of r of x because the remainder is 0. And that is it. If the remainder is not 0, it's not a factor. And that is according to the remainder theorem. And I said this in previous videos. If you do not know what the remainder theorem is, you have some serious issues right now if you're studying for the Regents and you have like a week left. You have a serious problem. If you don't know what that is, you got to go back and study it. And it is on my Facts You Must Know code for the Regents exam, but it is so important. It comes up on every test, and they're easy points, I promise you. It's honestly not that bad of a question. So anyway, that is how you do, if I get it right, that is how you do number 25. Moving on to number 26. The weight of a bag of pears at the local market averages 8 pounds with a standard deviation of 0.5 pounds. The weights of all the bags of pears at the market closely follow a normal distribution. Determine what percent of bags to the nearest integer weighs less than 8.25 pounds. So, we actually need to use the calculator. All right, we're using normal CDF in the calculator. Normal CDF. So, its average is 8 pounds. So that means that your mean or your mu, mu, in the calculator, that's going to be 8. We need to find the lower bound, and we need to find the upper bound. All right, so the lower bound, it says to the nearest integer weighed less than 8.25 pounds. So it means 8.25 pounds or less. So your lowest bound is actually 0. Your upper bound is 8.25. That was kind of tricky to know that the lower bound was 0. And your standard deviation, they tell you, is 0.5. So what we're going to do is we're going to take all this information and we're going to put it into our calculator. Go to your calculator page, go to calculator, go to menu, go to statistics, go to distributions, then go to normal CDF. Lower bound is 0, upper bound is 8.25. Your mu or your mean is 8 and your standard deviation is 0.5. Click on OK. it is 0.69 or 69%. And it specifically says rounded to the nearest integer. That means you need to round it to the nearest percent. You can't write it as 0.69. You have to round it to 69 or convert it into 69%. Ladies and gentlemen, that is how you do this question. Moving on to number 27. Over the set of integers, factor the expression 4x to the third minus x squared plus 16 minus 4 completely. Okay, so we're going to group factor. Group factor this, group factor this. We need to take out the GCF of these two terms. The GCF of 4x to the third minus x squared is x squared. You're left with 4x minus 1. Be so very careful with that minus 1. Over here, the greatest common factor is 4. Plus 4, you're left with 4x minus 1. I always like to double check. If you take that positive 4 and you redistribute, do you get 16x minus 4 back? And yes, you do. So we know that we did it correct. Happy, happy. It's a weird face. Anyway, so now we're going to combine and simplify. So when I say combine, you're combining the x squared term with the 4 term, and you're going to get some sort of factor. Okay? So we get x squared plus 4, 4x minus 1. We only write that once. Can we factor any further? No. That's your answer, folks. And if you thought, hey, Trev, I thought we could factor this. No, that is not the difference of two perfect squares because you're adding. That's not the difference of two perfect squares. We are done with that question. Moving on to number 28. The graph below represents the height above the ground h in inches of a point on a triathlete's bike wheel during a training ride in terms of time t in seconds. Identify the period of the graph and describe what the period means in the context of the problem. So after this exam was given, I was looking at the answer key, and I would say that the answer key for this question was incredibly unfair. So you have to be so specific with your wording to get the full 2 points. So here's what it is. The period on a graph is the amount that one cycle takes place, okay? So if you look over here, folks, this is one cycle, okay? So the period is 2/3 seconds, okay? So we're going to say that the period is 2/3 seconds, or 2/3 seconds, and it represents the amount of time it takes the bicycle wheel to complete one full rotation. You have to be so specific. That would give you full credit, folks. That would give you the plus 2 points. Happy, happy. That will give you 2 points on the exam. So that's how you do that question. Not too bad. You just have to be very specific with your wording. Moving on to number 29. Graph y equals 40 times 0.85 raised to the 2x minus 6 on the set of axes below. This, folks, is a very simple question. You take the 2 points and you run with it. That's all they're asking you to do is graph it. They want to know how well can you type a function into your graphing calculator, because I have to admit that they do give you kind of a complicated thing to type into your calculator, but it's not awfully terrible. Go to your calculator, go to the graph page. Type in 400 times 0.85 raised to the 2x power minus 6. And you can't see it. So we got to go to menu, go to window zoom, window zoom fit. Okay? And that fits it perfectly. That's actually too big. So that's up to 11,000. We want to stop at 400. So I'm going to make that number 400 right there, okay? I'm going to make the number 400. I'm going to make this number down here. I'm going to make this 0. I'm going to make this 0 as well. I'm going to make that 10. Okay, that's much better. So I made that 400, made this 10, and made both of these numbers down here 0. Okay, so I'm going to do Control-T, so our graph needs to look something like that. I'm going to do Control-T. And just to save some time, I'm not even going to go flip back and forth. I'm just going to tell you what the values are. Now, it's okay if you use approximations, folks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 0, it's 394. At 1, it's 283. At 2, it's approximately 203. At 3, it's approximately 145. At 4, it's approximately 103. At 5, it's approximately 73. At 6, it's approximately 51. At 7, it's approximately 35. At 8, it's approximately 24. At 9, it's approximately 15. And at 10, it's approximately equal to 10. So what we have to do is graph all those numbers. So just do it to the best of your ability, since they counted by, I believe they counted by 20s. 20, 40, 60, 80, 100. Yep, 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. Now I'm going to count by, now they counted by 0.5. So 0.51, 1.52, 2.53, 3.54, 4.55. Just keep on counting upwards until you run out of boxes. There we go. So let's go ahead and graph it. So 0, 394, that's somewhere up here. 1, 283, so 2, 220, 240, 260, 280, somewhere around there. 2 is around 200, like right above it. Okay. 3 is about 145, so 20, 40, right around here. 4 is 103, so it's right around 100. At 5, it's about 73, so 20, 40, 60, right in between 70 and 80-ish, so right in between that mark. 6 is 51, 20, 40, 50-ish, so right midway through. 7 is 35, so 20, 40, right around the upper middle part. And 8 is 24, so 20 right above that line. And 9 is 15, so 20 right around here towards the top. And that's midway through. So this is how you should construct your graph, like those dots, okay? So now, to the best of your ability, you're just going to connect those dots. I have a very hard time with this on my software that I use, so I'm going to try the very best I can. And forgive me if it's really gross, because it usually is. It's so challenging to you see, it's very challenging to draw on this. Okay, that's the best I'm gonna do. I could do it better with a freehand. All right, that's the best I could do. And we get y equals 400 times 0.85, 2x minus 6. And that is how you do that question. Pretty simple stuff. Number 30, solve algebraically for all values of x. And make sure that you check, because you really need to check your solutions. Now, we need to isolate the x by itself. But the problem is we have a square root of x. We cannot solve for the square root of x. We have to eventually square that term in order to get rid of that square root. So what I'm going to do is subtract the x on both sides. We get the square root of x minus 4 is equal to 6 minus x. Okay. Square both sides. We get x minus 4 equals 6 minus x, 6 minus x. Now we can FOIL this. First, outer, inner, last. X minus 4 equals 36 minus 12x plus x squared. Okay, now we're going to subtract the x and add the 4. Subtract the x and add the 4. So we get x squared minus 13x plus 40 set equal to 0 and solve. So we get, well, what adds to negative 13 and multiplies to give you 40? So we get x minus 5 and x minus 8. Yep, x minus 5 and x minus 8. Set it equal to 0, then solve for x. T-bar, x equals 5, x equals 8. Now what we need to do is check those answers, because you need to have 100% certainty that you know that those two answers are correct. So we're going to check it. We're going to check x equals 5 first. The square root of 5 minus 4 plus 5 equals 6. Well, the square root of 5 minus 4 is 1 plus 5 equals 6. Does 6 equal 6? And yes, it does. So 5 works out. Let's try x equals 8. So we have the square root of 8 minus 4 plus 8 equals 6. Square root of 8 minus 4, that's the square root of 4, which is 2, plus 8 equals 6. Does 6 equal 6? No, I'm sorry. Does 10 equal 6, I meant to say. Does 10 equal 6? And it does not. So this answer blows up. Reject it. It's extraneous. Reject it. So your answer, folks, is x equals 5. Actually, let me put in swirly brackets. X is equal to 5. That's it. Done. Pretty simple problem. Not too bad. How are we doing so far? I hope we're doing well, because I know that we did the problems first, right? Yep. Okay, moving on to this question. Write the cube root of x times the square root of x as a single term with a rational exponent. So, we have x to the 1/3 times x to the 1/2. Wait a minute, Trevor. Where am I getting that 1/2? Where are you getting that 1/2 from? Well, you have to be very careful here. There's a 2 as an index here. This is the square root. And remember, it says rational exponent. So your job is to take the radical sign and convert it. So remember, it's always expresses the root with the radicand raised to the superpower. And this is the same thing as n to the power over root. So that's what I'm doing, is I'm converting the radicals into exponents. Okay? So we have x to the 1/3 times x to the 1/2. What I'm going to do is I'm going to add those exponents. So we have x to the 1/3 plus 1/2. The problem is with this is you need to use an LCD, because 1/3 plus 1/2 cannot be added unless you do have a least common denominator. So the least common denominator between 3 and 2 is 6. 1/3 plus 1/2, I'm going to multiply this by 2. I'm going to multiply this by 3. We get 2 over 6 plus 3 over 6. That's 5 over 6. Okay? So this, ladies and gentlemen, is your new exponent. So we're taking x to the 5/6 and expressed as a rational exponent. We are done, ladies and gentlemen. This is your answer. And we're done. Sweet. These are not so bad so far. It's going to get worse, though, I believe, if I'm going through this correctly. Actually, you know what? Yeah, the part 2s were kind of fair this time around. They weren't that bad. Unless you don't like probability like me. Number 32 says, data collected about jogging from students with 2 older siblings are shown in the table below. Using these data, determine whether a sibling with 2 older siblings is more likely to jog if one sibling jogs or if both siblings jog. Justify your answer. So what I'm going to do is I'm going to add these up. So I'm going to add this number over here plus this number over here. And we got 2269. Just so I know for the one because it's saying in the instructions one sibling or both siblings, so we eventually need these totals. And this total over here is 1780. So let's go ahead and solve this. Here we go. So the probability that the student jogs, given that one sibling jogs, is equal to what? Well, if the student jogs, so the student jogs right here, given that one sibling jogs, that is 416 out of 2239, okay? That is the probability, because it's saying what is the probability of this and the probability that both siblings jog with the student and which one's greater. So this probability right here is with the one sibling jogging. So this is approximately equal to 0.186, okay? Now the probability that the student jogs given that both siblings jog is, let's see, both siblings jog. Let me get rid of this. Both siblings jog and the student jogs. That is going to be 400. So we have 400 over 1780. And that's approximately equal to 0.225 when you plug it into the calculator and get a decimal. So now what we're going to do is just evaluate which ones has a greater chance of happening, right? So we're going to say that, okay, well, clearly this number is greater than this number, because if we express these as a percent, that's about 19%, and this is about 23%. So we're going to say that it is more likely to jog if both siblings jog, since 22.5% is greater than 18.5%. So it's a better chance to jog if both siblings jog, all right? And that is how you complete that question. Not too bad of a probability question. You got to think that these are 2 points, so they're not that much. So there can't be that much work. These are my favorite questions ever. I love these things. So if you don't, then I will help you out here. So 33 says, solve the following system of equations algebraically for all values of x, y, and z. So here's the thing first, ladies and gentlemen. I want you to get the right answer every single time. What I recommend is if you have the TI Inspire, and if you don't, I don't know what you're waiting for because I advertise it way too many times, is go to your calculator page and solve the system before you even attempt to solve it by hand. What do I mean? Well, go to menu, go to algebra, click on solve system of linear equations. We're working with 3 equations, variables x, y, and z. Click OK. I am going to type in my equations into the calculator. Okay. So once you type these into your calculator, you're just going to press enter. And what's going to happen is it's going to spit out the 3 answers that you need. And the goal here is to make sure that you get these answers along the way. Because if you mess up one of the letters, you know for sure, hey, I messed something up here. I got to go back and fix it. So it's just nice to have the answers ready for you at all times. So your x is 0, your y is 2, your z is -1. We know those answers. So now let's go ahead and solve it by hand. What I tell students is to take the first 2 equations, eliminate a variable. Eliminate any variable you want. In this case, I would eliminate the x's just because we're dealing with the number 2's, and it's a little bit easier to deal with the number 2's compared to the number 4 and 6. Fair? So we have x plus y. Let me write that a little bit neater. So we have x plus y plus z equals 1, and 2x plus 4y plus 6z equals 2. I'm going to multiply the top by a -2 to cancel out those x values. Okay? So we get -2x minus 2y minus 2z equals -2, and 2x plus 4y plus 6z equals 2. We're going to cancel out those x's. Now we're going to add these up. 4y plus a -2y is 2y plus 4z equals 0. Okay? So we have this equation. Now I'm going to take the bottom 2 equations and eliminate the same variable. You can't just go eliminate another variable if you want to. You have to eliminate the same variable. It has to be the x. Here we go. So you have 2x plus 4y plus 6z equals 2. Oops. And -x plus 3y minus 5z equals 11. So we want to multiply the bottom by 2 to get rid of those x's. Multiply the bottom by 2. I need a different color. Multiply the bottom by 2. We get 2x plus 4y plus 6z equals 2. And let's see here. -2x plus 6y minus 10z is equal to 22. Is that right? Did I do everything right? Yes, I did. Okay, good. Now we're going to add these up. Those 2x's cancel. We get 10y minus 4z is equal to the number 24. So now what we're going to do, which is nice, is we're now down to the y and the z. So what we're going to do is we're going to combine these 2 equations and eliminate another variable to solve for the other. So I'm going to line these up. We get 10y minus 4z is equal to 24, and 2y plus 4z equals 0. Now what's nice is the z's cancel. Sweet. Once we cancel those, now we're just left with y terms. So we're going to add these up. We get 12y is equal to the number 24, divide by the number 12 on both sides, and we get y is equal to 2. Now, once we solve y equals 2, and we know that that's the right answer because we got it on our calculator, once we get y equals 2, what I'm then going to do is called back substitution. Back substitution meaning that you're taking that 2 and you're plugging it back into one of these equations. Now, you might be thinking to yourself, Trevor, why not plug it back up into one of these? The problem is this. You have 3 variables still, and you only eliminated 1. You still have 2 more left. It's easier to plug it into the equations that you found, get another variable, then plug it into the 3 variables. If you don't know what I just said so far, let me explain. So I am now going to solve for z. Why am I solving for z? Because that's what I have left in here. Okay? So we have 2y plus 4z equals 0. I'm going to take that 2, plug it in. 2 times 2 plus 4z equals 0. 2 times 2 is 4 plus 4z equals 0. Okay? Subtract that 4 on both sides. We get 4z is equal to negative 4. And then just divide by the 4. And you get z is equal to negative 1. Now, just to confirm, did we get that? Yes, we got negative 1 on our calculator. We're that much closer. So now once we have y equals 2 and z equals negative 1, we're going to take those two numbers. We're going to plug it into the first one. X plus y plus z equals 1. That is the easiest one to deal with. So let's just go ahead and do it. Solve for x. Now that we have the two variables, we can plug it into the 3-variable equation. So we have x plus y plus z equals 1. So we have the, we are trying to find x. We have the y, it's plus 2. We have the z, it's plus a negative 1. That equals 1. So you have x equals, let's see, 2 minus 1 is 1. Move that 1 on both sides. We had x equals 0. And that, ladies and gentlemen, is the answer because, again, shown on our calculator, we got it right. So to write your solution, it is in swirly brackets, 0, 2, negative 1. Make sure it's an XYZ term. XYZ, it has to be in the proper order, just so the reader knows what you're talking about. And that, ladies and gentlemen, is how you do that question. Pretty simple stuff. 0 to negative 1. Moving on to number 34. Jim is looking to buy a vacation home for $172,600 near his favorite southern beach. Oh dear, do I want to go to Florida again? The formula to compute a mortgage payment M is M equals P times R times 1 plus R to the N, divided by 1 plus R to the N minus 1, where P is the principal amount of the loan, R is the monthly interest rate, N is the number of monthly payments. Jim's bank offers a monthly interest rate of 0.305% on a 15-year mortgage. With no down payment, determine Jim's mortgage payment rounded to the nearest dollar. So there's a lot thrown at you. I get it. There's a lot of stuff here. Let's break it down slowly. First of all, we're trying to find Jim's mortgage payment with no down payment. No down payment means you walk up to the bank. Let's say you're going to Chase Bank, and you say to Chase, listen to me, I want to buy a house. I have no money, and I need you to lay out a mortgage plan for me. Tell me how much I'm going to pay. First of all, no bank is going to give you a mortgage if you don't have a down payment because they want to get their interest immediately. So that's so unrealistic. But anyway, we're trying to find the mortgage. So the mortgage is this formula up here. Well, that's what we're trying to find, people. The mortgage is your big question mark that we're trying to find. The principal. The principal is how much money is or how much money the house costs. So that's $172,600. So the principal is $172,600. The little r, lowercase r, that is the rate of 0.305%, but you have to convert it to a decimal, which is 0.00305. And that's it. Then we have, let's see, capital N. Capital N is, hold on a second, where I saw it here. Capital N is the number of monthly payments on a 15-year mortgage. Well, capital N is going to be 15 years multiplied by 12 months because they're asking for the monthly payment. So 15 times 12, that is 180 payments. Okay? So you just take the 15 years times the 12 months in a year, you get 180 payments. So let's go ahead and plug all this information into our formula and let's calculate the mortgage. So the mortgage is equal to $172,600 times 0.00305 times 1 plus 0.00305 raised to the 180 divided by 1 plus 0.00305 raised to the 180 minus 1. Okay. So now I'm going to take all this information, I'm going to plug it into the calculator. Plug it into the calculator. So we get, not my graph page, I don't know what I'm doing here. Go to your calculator page. Type in 172,600 times control division 0.00305 times 1 plus 0.00305 oh my god, 0.00305 raised to the 180 power divided by 1 plus 0.00305 raised to the 180 minus 1. I know it's a lot to type in, but it's so worth it in the end because you feel accomplished at the very end. We have $1,247.49. It says round it to the nearest dollar. Remember, folks, if it's 50 cents or more, you round it up. It's exactly 49 cents. You have to keep it at $1,247. So the mortgage is $1,247. Ladies and gentlemen, that is the monthly payment that Jim has to pay per month to pay off the house. Okay, that's how you do that part of the question. For the second part, it says algebraically determine and state the down payment rounded to the nearest dollar if Jim needs to make in order for his mortgage payment to be $1,100. So this is where it gets a little interesting here and it gets tricky. Let's take it slow. The mortgage payment is the mortgage formula is still the same. It's mortgage equals P times all this stuff. Oh, get that rid of that. R raised to the capital N divided by 1 plus R to the capital N minus. Okay, so that's still your formula. But the difference is they're telling you that the 1,100 is capital M. They're telling you that that's your new mortgage payment. So we have 1,100. That is equal to the principal. Now, the principal is still the same. The house costs the same. So it's still 172,600. But the difference is Jim is now making a down payment. So it's 172,600 minus X, where X is now your down payment. So we're trying to solve for a value of X, or the value of X, that he needs to get his mortgage payment down to $1,100 a month, okay? You want to make your mortgage payment as cheap as possible, so he wants to put down a down payment, okay? So what we're going to do is leave it as that, and it's all the same stuff after the fact. It's still 0.00305 times 1 plus 0.00305 raised to the 180. He's still paying in 15 years. Divided by 1 plus 0.00305 to the 180 minus 1. So now what we're going to do is we're going to divide by this junk, all of that junk on that side. So 0.00305 times 1 plus 0.0030. Actually, you know what? Heck with that. I'm not even going to do it. I am going to tell you what this is as a decimal. If you actually type this garbage into your calculator, you're going to get a decimal. And your decimal is 0.007227655,819. It's just so much easier to write for me on the video. 0.07227655819. All that cancels with this. Okay? Now we get, when you simplify this down, you get 152,193.190645. You really don't want to round to the very end, so that's why these numbers are so gargantuan. Okay? Now I'm going to subtract the 172, 600. That should be a 6, not a 0. 600. Subtract the 172, 600. Okay? Those cancel. And we get, let's see here. When you subtract these numbers, we get negative 20,406.8093548 equals negative X. Let me just double check that information. 152,193.190645 minus 172,600. Yep, sweet. All right, and we just divide by that negative 1 to solve for X. So we get X equals and round it to the nearest dollar. So $20,407 because that's 81 cents. So you have to round it up. So ladies and gentlemen, that is the, what is that? That is the down payment that Jim needs to make to get that mortgage down. So he needs to lay out $20,407 the minute he walks into Chase Bank. And ladies and gentlemen, that is the answer to that question. Number 35. Graph y equals log base 2 of x plus 3 minus 5 on the set of axes below. Use an appropriate scale to include both intercepts. Yes, you need to show the y-intercept and the x-intercept. So I'm going to go to my graphing calculator. I'm going to graph y equals log base 2 of x plus 3 minus 5. And we get that stuff right here. Okay, so I'm going to do, so clearly the y-intercept is shown, but we got to go a pretty significant amount. We got to go up to like 30 to get that x-intercept. So I'm going to change my window settings. You don't need to do this, but I'm going to go from -3 to 30. I'm going to make that -4. I'm going to make this 4. Make that 1. Okay. So, ladies and gentlemen, this is how your graph should look on your graph page on your Regents exam. So, why did I pick x equals 3, x equals -3 over here? Because here's what I'm saying. The minute you plug in -3, that log value in there becomes 0. That can't happen. So this log actually has a vertical asymptote of x equals -3. And if you don't believe me, just go to the relation page and type in x equals -3, and you will see that this is, in fact, a vertical asymptote. And it never touches that line. So we want to go from x equals -3 all the way up to 30. Now, I'm not going to waste your time by showing you what it is in the table of values. I'm just going to write it down. I expect you to go ahead and get those values by yourself on the calculator. For those of you who do not know how to get the table of values, it's Control-T, but if I really had to tell you that because you didn't know, then you must have been sleeping the whole year. And through Algebra 1 and Geometry. So -3, but if it's your first time purchasing the calculator, Control-T. 1, 5, 13, 29. Okay, so these numbers are undefined. Well, that was kind of determined. -5, -4, -3.415. That is the y-intercept. -3, -2, -1, and it's approximately 0 at 29. So we need to use an appropriate scale. There are 10 lines here. I'm going to count by 3s to make this line over there 30. Because 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So, I may have skipped a number in there just because I was talking too fast. So, your x scale is by 3s. So, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And go negative. -3, -6, -9. Stop at -9 because you don't need to go any further. Then for the y-axis, I'm going to count by 1. So 1, 2, 3, 4, -1, -2, -3, -4. So let's go ahead and graph this. Let's go and graph all these points. So -3 is undefined. So we know that it's undefined. So that's a good thing that we know it's undefined. So it's undefined right over here. So we cannot pass that line, peoples. Can't pass it. So we go down to -2, down to -5. 1, 2, 3, 4, -5 right there. Okay. -1, -4. So it's right around there. Then we have our really weird y-intercept. So -3.4. It's right over there. Then we have 1. -3 right around there. Then we go to 5. -2. Then we go to 13. -1. Then we go all the way to 29. And we get 0. Beautiful. So now I'm just going to go ahead and draw to the best of my, best of my ability, that log function. Yes, I did it good this time. I drew it well this time. So y equals the log base 2 of x plus 3 minus 5. So that is how you graph it with your table of values and the proper axes. You have to include both intercepts. Be careful with that. Now there's a nice question that I enjoy. Describe the behavior of the given function as x approaches -3 and x approaches positive infinity. Oh, nice. So this is quite interesting. So they want you to determine what does the function do as x approaches this vertical asymptote. Well, as you can see, it's going down. Pretty simple stuff, right? It's going down. And as x approaches infinity, which is all the way to the right, off in the infinite direction, you're looking at it's rising. It's going up. So, but you need to put that in math terms. You can't be saying goes down, goes down, rises, whatever the heck that is. So what you need to say is this in notation. This is read as x approaches -3, y approaches -infinity. It's going down forever as x approaches this vertical line. It goes down forever, so that is the same thing as -infinity. And as x approaches infinity, your y value approaches infinity because it's going up forever. Listen to me. It goes up ridiculously slow, but it is going to infinity. It is. And we know that for sure. So, that's it. That's how you do that last part of the question. That is called end behavior, by the way, just in case you were curious. And if you are confused on end behavior, another reason why to download my Facts You Must Know code for the Regents exam, end behavior is actually covered on that packet. Moving on to the last part 3, then on to the part 4. Charlie's automotive dealership is considering implementing a new check-in procedure for customers who are bringing their vehicles for routine maintenance. The dealership will launch the procedure if 50% or more of the customers give the new procedure a favorable rating when compared to the current procedure. The dealership devises a simulation based on the minimal requirement that 50% of the customers prefer the new procedure. Each dot on the graph below represents the proportion of the customers who prefer the new check-in procedure, each of sample size 40 simulated 100 times. So again, they're taking that real-life example and they're making it into some ridiculous computer simulation. Now, assume the set of data is approximately normal and the dealership wants to be 95% confident of its results. Determine an interval containing the plausible sample values in which the dealership will launch the new procedure. Round your answer to the nearest hundredth. Folks, I get it. And this is why I say that you can't cheat off of these videos. Please don't do it. This is a lot of reading, and you need to know what it's asking you what to do. You need to know it. So what they're saying here is they want the 95% confidence interval, which 95% confidence means that you're taking the mean plus or minus 2 standard deviations. That's how you get your interval. And if you don't know that, you need to. You need to know it. 95% confidence means the mean plus or minus 2 standard deviations. So they tell us some information. You got to pick out the right information. The mean is 0.506. The standard deviation is 0.078. So what we're going to do is we're going to calculate the mean plus minus 2 standard deviations. So we get 0.506 plus 2 times the standard deviation of 0.078 and 0.506 minus 2 times 0.078, the standard deviation. This will give you 0.662. This will give you 0.35. So your plausible interval, ladies and gentlemen, is 0.35 to 0.66. That is a plausible interval that you need. Okay? That's a pretty simple part. Then the next part, it says 40 customers are selected randomly to undergo the new check-in procedure, and the proportion of customers who prefer the new procedure is 32.5%. The dealership decides not to implement the new check-in procedure based on the results of the study. Use statistical evidence to explain the decision. So here's what it's saying. It's saying that the 32.5% prefer the new procedure. If you look back at your interval, it's from 35% to 66% of people should like the new procedure. Okay? And that's the 95% confidence interval. That's 95% of the people surveyed. 32.5% is less than 35%. So that means that it's an unfavorable procedure that they're doing. So the dealership decides not to implement the new procedure. Explain that decision? Well, they're right not to implement it. They're absolutely right. So the dealership decided not to implement because 32.5% lies outside of the plausible interval. That's it. That's all you need to do. That makes the most sense, too. You're done with that question. And that's it. Moving on to the last question of this exam. It is a log question. Here we go. A radioactive substance has a mass of 140 grams at 3 p.m. and 100 grams at 8 p.m. Write an equation in the form A equals A sub 0, 1/2 raised to the T over H that models the situation where H is a constant representing the number of hours in the half-life, A sub 0 is the initial mass, and capital A is the mass T hours after 3 p.m. Wow. Okay. So A sub 0 is the initial mass. That's the starting mass. Laundry's done. So it is a starting amount. So it's 140 grams is the initial amount. So A sub 0 is 140 grams. Capital A is the amount of mass T hours after 3 p.m. So it's saying that there's 100 grams at 8 p.m. So that's your capital A. It's 100 grams. That's the amount after some time went by, right? The 1/2 still remains the same. Your lowercase t. Now, your lowercase t is the t in hours. How many hours went by? Well, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. 5 hours. And we leave H alone because H is the constant representing the number of hours of the half-life. We don't even know what that is. So we're going to take all this information. We're going to plug it into our formula. So 100 is equal to 140 times a half raised to the 5 divided by H power. That 5 needs to look a little bit better. Ladies and gentlemen, that's how you answer the first part of that question. That's all you need to do. Moving on to the next part, using this equation, solve for H to the nearest 10,000. So what we're going to do is we're going to take our equation that we literally just wrote, and we're going to solve for H. So remember, I don't know what's wrong with my 5s. I really don't. Okay. To solve for H, we need that H to be out of the exponent. We got to get it out. So we're going to divide by 140 first. Okay? So 100 divided by 140, that is 5/7 is equal to 1/2 raised to the 5 over H power. We're going to take that 5 over H and move it down to the front. So we get 5/7 is equal to 5 over H. Now, the minute you move an exponent down with a variable, you have to write the word log or ln. So I'm going to write log. So 5 over H, the log of 1/2. Now, once you take the log of one side, you must take the log of the other side. Now we're almost there. We are now going to multiply by the reciprocal of this, okay? Now, that's a little challenging for some of you, multiplying by reciprocals. That log of 1/2 is actually up in the numerator. So you are going to multiply by the reciprocal, which is, let's see here. Actually, you know what? Better idea. Let's not even do that. Let's go ahead and let's cross multiply. I like that a little bit better. I'm gonna change this. I'm gonna move that log up in the numerator just so I could save some room on my whiteboard. I'm gonna put this up here. Log of 1/2 divided by H. I'm gonna multiply or cross multiply, I should say. So we have log of 5/7 with an H up front is equal to 5 log of 1/2. Divide by the log of 5/7. Divide by the log of 5/7. Cancel those out. we get H is approximately equal to, and it says round to the nearest 10,000. That's 4 decimal places, ladies and gentlemen. So I'm going to type that into my calculator. Control division. 5 log, right? 5 log, yep. 5 log of a half divided by the log of 5/7. And we get 10.3002. 10.3002. That, ladies and gentlemen, is your value of H for that part. Oops. Okay, that's how you do that part of the question. Now, for the last part, it says determine when the mass of the radioactive substance will be 40 grams. Round your answer to the nearest tenth of an hour. So here's the thing. We're still using the same formula. The formula hasn't changed. It's still A equals A sub 0 times a half raised to the T over H. But this time, ladies and gentlemen, we're trying to determine when the mass is 40 grams. So now we're trying to find the time. You see how they're changing things on you? Now they want you to find the time of how long it takes to make this 40 grams. Okay? The initial amount is still 140. But this time, your capital A is 40. So we have 40 is equal to 140 times a half raised to the T divided by, now your constant, we just found that constant, that H. It's 10.3002. Now we got to go and solve for T. We're still using logs, ladies and gentlemen. Nothing's changed. We still need to isolate that T and solve it by using logarithms. So 40 divided by 140, that's just going to be 2/7 is equal to the log. Nope, I went too far. I went too fast. Whoops, my apologies. 2/7 is equal to 1/2 T divided by 10.3002. Okay, so I'm going to move this exponent down in the front. Remember, when you move it down, you got to write the word log. But once you take the log of one side, you must take the log of the other side. So this is the log of 2/7. Okay? Now, we're going to cross multiply again. Cross multiply. This is over 1. We're going to take this times this, and we are taking this times the 1. Okay? So we just have 10.3002 log of 2/7 is equal to T log of a half. Divide by the log of a half. Divide by the log of a half. Cancel those out. And you get T, when you type that into your calculator, I'm going to save you some time. Rounds to the nearest tenth, it's 18.6 hours. That's how long it will take to get a 40-gram total in your, or whatever radioactive substance they're measuring, 18.6 hours. And that, ladies and gentlemen, is a conclusion of this video. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. And make sure that you visit my website at www.nysmathregentsprep.com. Both of those links can be found in the description below. And I hope to see you soon.